So hi dear students, so today we are going to discuss the next important concept, that is the relation between molarity and normality. So it also comes under the topic expressing the concentration of the solution. So here initially we were discussing trying to understand each concentration terms. Now we are trying to derive the relation between these two. Okay, in this the most important relation is the relation between molarity and normality. So I don't want to simply write the formula so that you can by heart that. Instead it is better we will understand how we are deriving it, so that if you forgot the formula also you can easily arrive at that. Okay, so I will start from the concept strength of a solution. So those who are not knowing the strength of the solution, please listen to my previous lectures. There we have concluded that strength of a solution can be represented in three ways basically. Two ways I have represented here. That is, the strength of the solution can be written as molarity into molar mass of the solute, and the another way of representing that is strength of the solution is equal to normality into equivalent mass of the solute. So I consider these as equation 1 and equation 2. Okay, so on seeing this we know that LHS, that is both these equation 1 and 2, LHS are the same, strength of the solution. So I can say RHS should also be equal in that case. If LHS are equal, then RHS should also be equal. Okay, so we can equate these two. So on equating we can write like molarity into molar mass of the solute is equal to normality into equivalent mass of the solute. Okay, molarity into molar mass of the solute is equal to normality into equivalent mass of the solute. Now from this I am writing in terms of normality. So normality is equal to, I am taking the equivalent mass of the solute below denominator. So I can write molarity into molar mass of the solute divided by equivalent mass of the solute. And we know that equivalent mass, this also we have defined in our previous lecture. Please listen to that. So equivalent mass can be written as, the fundamental formula is molar mass divided by valency factor. Correct? We can write it as equivalent mass is equal to molar mass by valency factor. So now tell me, we know that molar mass of the solute is common to these two, so I can cancel these two. Okay, so that what will happen, I can rewrite this as this equation as normality is equal to what will happen, valency factor will come to the numerator, so I can write molarity into valency factor. Okay, so if I represent this using symbols, how I can write it? Normality can be represented by the letter N. So N is equal to, molarity is represented by the letter capital M, and valency factor is represented by the letter small n. So I can say that normality is equal to molarity into valency factor. Okay, so what are the other conclusions we can derive out of this? Can you think and say? I know that what can be the minimum value of valency factor, or what is the minimum value of n. We know that n is valency factor. So n can have a minimum value, n is equal to 1. That is the minimum value. Why? Because minimum value. Because the valency, the least valency that is possible is 1, and the maximum valency possible is 7. It can go like that, right? So minimum value is 1. So how this equation can then be written if n is equal to 1? If n is equal to 1, n will be equal to m. And now think about the second situation where n can be 2 or it can be 3 like that. That means n is having a value greater than 1. So if n is greater than 1, so n is greater than 1 means how this equation will come to be? I can write n will be, in that case n will be greater than m. Why? Because m into 2, m into 3, this value will become equal to n. Then m will be n divided by that particular number. So m will be less. So I can write n is greater than m. So on concluding or combining these two, finally I can write, how I can write the final equation? I can write like the relation between n and m will be, n can be either greater than or it can be equal to m. Understood? So this is my final conclusion. So I can say normality can be greater than molarity or it can be equal to. So that is why greater than or equal to molarity. So generally speaking, this is the one you should remember, very very important. Normality is equal to molarity into valency factor n. Okay. So next I will try to do one question based on this, and next then we will switch to the next topic. Hope you understood the concept. Okay, go through the question. The question is, calculate the normality of 1.5 molar H3PO4 is. Okay, so they are asking me normality, and what they have given here, molarity. So I know the relation between normality and molarity. I know that normality is equal to molarity into small n. Small n is my valency factor. Okay, now tell me, here valency factor can have different values. Here an acid is given, H3PO4. So what should be the valency factor n? Its basicity, that means replaceable hydrogens is what is its valency factor. So I know that for H3PO4, basicity, what is basicity? Again I am telling, number of replaceable hydrogen ions. So the basicity is 3. Okay, and also don't by heart, if there are 3 hydrogen, its basicity will be 3. No, not like that. There can be case where only 2 hydrogens are donatable. So I will give a chart for different acids and its corresponding basicity. So for H3PO4, the 3 hydrogens are donatable as H+. So we say its basicity is 3. So if basicity is 3, that means the valency factor n is equal to 3 here. So I can calculate normality is equal to molarity. Molarity is what is the value? 1.5 into the valency factor n, which is equal to 3. So I can say 15 into 3, 45. So 1.5 into 3, that is nothing but 4.5 normal, capital N. So this is the answer. Okay, so I hope you understood how to do this. Okay, so next we will see the next topic, that is how to represent molarity in terms of density. Very very important. Okay, so listen here. So next we are going to learn the relationship between the molarity and density of the solution. This is also very important because I can say this is the most repeated question for Neet as well as JEE mains. Okay, so just we will see, this is also very simple concept. Just we will see how it is. So we know, as per our definition, molarity is what? Actually molarity of a solution, very simple, number of moles of the solute divided by volume of the solution in liters. Suppose if I want to say volume of the solution, I need to express it in ml. What I should do? I need to write liters, means I should convert this into ml. Ml means what I can do? We know that 1 liter is equal to 1000 ml. Correct? 1 liter is equal to 1000 ml. So if I want to write in terms of ml, means what should I do? I should divide by 1000. Then only it will becomes in terms of, again in terms of ml, but it will be again in terms again it will be liters only. Okay, so number of moles of the solute divided by volume of the solution in ml multiplied by 1000. So if it is directly in liters, means this 1000 will go. So if it is in ml, means what should be there? It should be multiplied by 1000. Okay. Okay. Now tell me, what is density of the solution? We know from the basic fundamental formula, density is mass by volume. Correct? So density of the solution can be written as mass of the solution by volume of the solution. So here mass of the solution I am taking in terms of gram and volume of the solution in terms of ml. So it is gram per ml. Okay, now volume of the solution, how I can rearrange? So volume of the solution in ml, it can be rewritten as mass of the solution by density of the solution. Now I will substitute that here actually. Okay, so I can substitute volume of the solution as what? Mass of the solution divided by density of the solution. And you can see here number of moles of the solute is what? Weight in gram of the solute divided by molar mass of the solute. So weight in gram of the solute divided by molar mass of the solute, then multiplied by 1000. Okay, so up to this I hope you understood. Now how we can rewrite this formula further? So if you see here, I can further write it as molarity can be represented by the letter capital M. Okay, so molarity can be represented by the letter capital M. So M is equal to weight in gram of the solute. So I am using W, gram, to represent that, and molar mass of the solute. So molar mass of the solute, I am using another symbol M for that. I will write it as molar mass itself so that you won't get molar mass of solute. Different people use different denotations, so I don't want that to happen. So weight in gram of the solute by molar mass of the solute divided by, so this is in bracket, multiplied by 1000 divided by mass of the solution and density of the solution. So I will represent small m for mass of the solution, and density of the solution I am representing using the letter D. Okay, so how I can again further write it as? So this can be further rewritten as, listen. Okay, so I am taking, we know this is A by B divided by C by D. So this will go to the numerator. I can write M is equal to weight in gram multiplied by, okay, so weight in gram multiplied by density, then weight in gram multiplied by density, then molar mass of the solute, molar mass of the solute, then into small m. Small m is mass of the solution, numerator multiplied by 1000. So here two things you should remember. Here density, what is the unit actually? It is not per liter, we are taking it as gram per ml. This is the unit we are taking. And molar mass of the solute will be fixed one. Here also weight in gram we are taking, and here this one, this is also very important. M stands for what actually? M stands for mass of the solution in grams. Very important. So I can say this is my final equation for molarity as well as with the density. So please remember this equation also for your exams. This also can come for the exams, and you can score good marks because this is a most repeated question. Okay, so now we will try to do one question based on this so that you will get a clear clarity how we can apply this formula. So listen, I have written the question. So what is the question here? Find out the molarity of 1 liter of 93% H2SO4. 1 liter of 93%, bracket you could see weight in gram divided by W by W, mass by mass. Okay, W by W, H2SO4. Density of the solution is given as 1.84 gram per ml. Okay, so we know the formula. Molarity is equal to, okay, molarity is equal to weight in gram multiplied by density of the solution into 1000 divided by molar mass of the solute multiplied by mass of the solution in grams. Now please interpret the question, very important. They are asking the molarity of 1 liter of 93% H2SO4. So how will you understand 93% H2SO4? I can say that 93 percentage, since percentage is given, it means in terms of 100. So in terms of 100 means what is the meaning? What is the W by W? We have learned this, correct? Mass of the solute by mass of the solution. You remember percentage W by W, V by V, M by V. Okay. So from this I can understand that 93 W by W means 93 gram of the solute is present in W, 100 gram of the solution. That is mean by 93 percentage. Okay. I am writing here 93 gram of the solute of solute is present in 100 gram of the solution. Okay, so this is the meaning of 93 percentage H2SO4. Very important. Now weight in gram, how much is given? 90. I know that in 100 gram how many amount of solute is present? 93 grams. So I can write weight in gram is equal to 93. Now density of the solution, so I know 1.84 gram per ml into 1000 divided by molar mass of the solute. Who is the solute here? Sulfuric acid, that is present in water. So sulfuric acid is my solute. Sulfuric acid molar mass means two hydrogen atoms. So 2 into 1 2, sulfur 32, oxygen 16. 16 into 4 64 plus 32 96 plus 2 98. So I am substituting 98 here. Mass of the solution, this is very important. Here most of the students have a doubt, sir, molarity of 1 liter they are asking, right? Correct, 1 liter only they are asking, but here you please listen, 93 percentage means 93 gram of the solute is present in 100 gram. Since we are taking 93 gram, 93 is present in how much gram of the solution? 100. Understood? So suppose they have given some other values, not percentage, then you don't want to keep here 100. So percentage comes means 93 gram of the solute is present in 100 gram of the solution. So you substitute 100 gram. So on cancellation you will get the final value as 78.68 molar. Very important, most repeated question. Okay. So they usually give it in terms of 93 percentage, but in bracket they will clearly mention it is W by W or V by V or W by V. So please listen to this percentage mass by mass or volume by volume or mass by volume ratio in my previous lectures, then you will get a clear idea. Okay. So I hope you understood this stuff. Then we will go to the next question. Okay. Hi dear students. So in the last class we were discussing on the topic the relation between molarity density. Okay, I was just explaining that. So I am now adding a term molarity density and mass percentage. Okay, so if you ask me is there any difference between the last class derivation and this class derivation, I will say nothing. Only thing is that I am going to do few rearrangements. Okay, so in the last class we have seen the equation, right, like molarity M is equal to weight in gram of the solute into density of the solution multiplied by 1000 divided by molar mass of the solute into mass of the solution in gram. So I told you can use directly this formula to link between molarity M and density of the solution. Correct? So we have done one question also. So many a times students used to come to me and say that, sir, in most of the books, sir, this formula is not available. I will tell the reason why it is like that. So I have first taught you the basics. Now I am going to rearrange this formula in a more appropriate way. And most of the book gives only that formula. So I can say most of the books give you a formula that links between molarity, density and one more term that is called mass percentage. So I will teach you how that rearrangement is being done in this equation. Okay. So listen here, very simple. So here you know that weight in gram of the solute multiplied by density of the solution multiplied by 1000. So first, as part of the first step, I am splitting this 1000 into 2. I can write 1000 as 100 into 10. Okay, I hope you know max. Okay, so 1000 can be written as 100 into 10. So I am splitting in the numerator. You can see here weight in gram of the solute. I have taken 100 here into 100 into density of the solution, then remaining is into 10. So again this multiplied, you will give the same value. Okay, in effect there is no change, but just I have split it like this. Now in the denominator you can see initially I have written molar mass of the solute here. Now I am rearranging, I am keeping mass of the solution first, then multiplied by molar mass of the solute. There is no difference, like you can multiply 3 into 4 or 4 into 3, both are same. Similarly, so mass of the solution I have written first, then molar mass of the solute. So why I have written like that? Now if you see this thing that is in the box, okay, something that is written in the box, please look this. Now you may find this area very familiar to you because you have already learned this. What is this one? Weight in gram of the solute divided by weight of the solution or mass of the solution multiplied by 100. So you know mass percentage is W, weight in gram of the solute, divided by weight of the solution or mass of the solution multiplied by 100. If this value is only there, we can say it is mass fraction. But when it is multiplied by 100, this whole scenario that is present in the box, it will become mass percentage. So I can rewrite the formula. Molarity is equal to mass percentage into density of the solution multiplied by 10 divided by molar mass of the solute. Okay, so I hope you understood. This formula you could see in lot of books, because this is what at the end of the day they have given in the books, but there is no difference. You have just rearranged here. So for making you to get a better clarity, I have given both formulas. Okay, but I may say this formula is very easy to remember, and also from the question you will not get any doubt when you use this formula directly. Okay, so I hope you understood this relation. So we will do one question based on this, and then we will switch to the next topic. So listen here, I hope you could see the question. Question is very direct forward. Calculate the molarity of 40% NaOH. Given that the density of the solution is 1.2 gram per ml. So how we will decode this question? Very simple. We should first understand that NaOH is the solute here. It is mixed with something to form a solution. So 40% NaOH means what? 40 gram of NaOH is present in 100 gram of the solution. That is mean by 40%, because we know that mass fraction. Okay, 40%, they should exactly give W by W to make it more clear. Okay. Okay, suppose if they have not given, assume that W by W. In that case, what that means, W by W means 40 gram of NaOH is present in 100 gram of the solution. Okay, now next thing. Okay, it is mentioned here, W by W. Okay, so the density of the solution is given as 1.2 gram per ml. So we know the formula, molarity is equal to mass percentage. So mass percentage is directly given, that is 40, and density that is given 1.2 gram per ml into 10 divided by molar mass of the solute. Now mass percentage we know it is 40 multiplied by density of the solution, that is 1.2 multiplied by 10 divided by molar mass of the solute. Here solute we have taken here is sodium hydroxide, NaOH. So sodium we know its mass is 23, oxygen we know its mass is 16, hydrogen we know 1. So 23 plus 16, 33, 39 plus 1, 40. So we will get the molar mass of the solute as 40. So that we have substituted here. So this 40 and 40 will get cancelled off. So 1.2 into 10 we will get 12 molar. To indicate it is 12 molar, I have kept capital M. So I hope you understood. In the previous way, what we do, in the previous formula without mass percentage, we know that 40 gram of the solute is present in 100 gram of the solution. So there we substitute mass of the solution as 100 gram and mass of the solute as 40 gram. Both methods are correct, but this one is more straightforward. That is what. Okay. So we will go to the next topic. So next topic we are going to deal with here is the relation between molality, small m. Okay. Hope you remember the term molality and mole fraction. Okay. This is also one important topic. They used to ask question based on these two. Okay, so we will see how to do that. Very simple. To derive this one, first we will say we take a binary mixture. Binary mixture means you have two components into that. Here we assume A as the solvent and B as my solute. Okay, A is my solvent and B is my solute. Now, can you tell me what is the mole fraction of B? So mole fraction of B means mole fraction of the solute. We have already learned from the definition, we know that mole fraction of the solute is equal to number of moles of the solute divided by number of moles of the solvent plus number of moles of the solute, or total number of moles. Okay, since it is binary mixture, we have solute, we have solvent and solute. So we say number of moles of solvent plus number of moles of solute. So similarly, can you say what is the mole fraction of solvent XA? We can write it as number of moles of the solvent divided by number of moles of the solvent plus number of moles of the solute. So these are two fundamental equations we have already learned. Now I am dividing this equation 1, okay, and this is my equation 2. So equation 1 divided by 2. I am doing equation 1 divided by equation 2. So I can say that XB divided by XA is equal to NB by NA plus NB divided by NA by NA plus NB. So we know that denominators are same, so these two will get cancelled off and you will get NB by NA. Clear? Until now it is clear, I hope. So now I am going to write number of moles of the solvent. Okay. We learned from our first class what is number of moles. We have the basic fundamental formula for number of moles. So number of moles of any substance is equal to weight in gram of that substance divided by molecular mass of the substance. This we have learned in our first chapter, basic concepts of chemistry. So here I am number of moles of the solute I am keeping as such, and number of moles of the solvent I am rewriting it as weight in gram of the solvent divided by molecular mass of the solvent. So that is going upside, I can say molecular mass of the solvent. Then I am doing one more thing. I am multiplying 1000 on the numerator and the same thing I am multiplying on the denominator. Okay, this is I am doing it. So if you multiply on the numerator and denominator, it will not make a difference, I hope. So I have written like this. Now what I am going to do is I am just rearranging it so that XB by XA is equal to NB by WA. 1000 I am taking inside, so into 1000 into MA is going that side, MA by 1000. Okay, now please look at this section. What is this section stands for? Or just to try to read the meaning of NB. That means number of moles of solute. B stands for solute. So that means number of moles of the solute divided by WA. That means weight in gram of the solvent multiplied by 1000. Please tell me what does this means actually. So this box indicates molality. Molality, what does it states? Weight, we know that number of moles of the solute divided by weight in gram of the solvent in kilogram. So into 1000 means this weight in WA will be in grams, as you know already. So here weight in grams, so to grams can be converted to kilograms, so that's why 1000 is coming there. So I can say this whole box is molality. So how I can rewrite this equation now? So I am rubbing this. So now you can see here I am going to rewrite this equation. I'm going to rewrite this equation as XB by XA is equal to molality multiplied by MA. MA means molar mass. We can say molar mass of the solvent divided by 1000. Okay. So this is the fundamental formula. I can say you need to learn. Okay, and there are sub conditions we can apply here. So how is the sub conditions applied here? We can write it as XA. XA can be written as 1 minus XB. This we have already learned because the sum of mole fraction is always equal to 1. So XA is equal to 1 minus XB. This how I have got it from XA plus XB is equal to 1. We know that sum of mole fraction of all the components is equal to 1. So how I can rewrite now? XB by 1 minus xb is equal to molality into MA, molecular mass of the solvent, divided by 1000. Correct. So again I am going to derive one more condition out of this. What is that condition? Okay, the condition is very simple. If I am assuming xb is very less, so xb means what? Xb is very less than 1, very much less than 1. If xb is very less than 1, that means the solute concentration is very less. That means it's a very much dilute solution. In that case, how I can rewrite this equation again? I can rewrite it as I can ignore this. In this case, xb is very much less than 1 means I can ignore this area. So the equation will rearrange to xb is equal to mole fraction of the solute is equal to molality into molecular mass of the solvent multiplied by 1000. Okay, so this is the final equation. So this condition will be applied when you will apply this. If the solution is very dilute, that means the mole fraction of the solute is very less. Otherwise you can use the first fundamental equation. So I hope you understood this fundamental concept of deriving the relation between molality, mole fraction, molality and mole fraction. Please remember it is molality. Okay, so next we will go to the next topic. Hi, so in the last session we have seen the relation between the molality and mole fraction. Now we will do a question based on that concept. Okay, I hope you are able to read the question. The question is, the mole fraction of urea in its aqueous solution is 0.2. Okay, calculate the molality of the solution. So first we will try to interpret the question. So mole fraction of urea in its aqueous solution, that means urea in aqueous solution, so urea mixed with water. So my solute here is urea and it is mixed with water, so that the mole fraction of the urea is given as 0.2. Okay, and they are asking you to calculate the molality. And I know how to link between mole fraction and molality. So I will use my fundamental formula xb by xa. So here B is the solute, that is urea, and A is the solvent, that is water here. So I use the fundamental formula, okay, that is xb by xa is equal to molality into molecular mass of the solvent, that is A, solvent, divided by 1000. Now you know that xb stands for mole fraction of the solute, that is urea, that is given in the question as 0.2. So that I will directly substitute here. So if we know it is a binary solution, urea and water is only present. So if urea 0.2 is the mole fraction, then what will be the mole fraction of water? It is easy, I can easily subtract from 1, because sum of mole fractions of every component will be equal to 1. Since it is binary, I can say xa plus xb is equal to 1. So xa will be equal to 1 minus xb, that is 1 minus 0.2, that is 0.8. Now molality, that is what we need to find out, into Ma. Ma stands for molecular mass of the A, that is solvent, which is water. So Ma is molecular mass of the solvent, water, that is equal to 18. 2 hydrogen, 2 with oxygen 16, 16 plus 2, 18. So I have substituted 18 here, divided by 1000. So on rearranging, 1000 will come over here. So I can say 0.2 by 0.8 is equal to 2 by 8 into 1000. 18 will come to the denominator. So if you do it, what will be the answer? So I can say 2 by 8 is nothing but my 1 by 4. Okay, and this 4 will get cancelled with 1000 as 250, because 250 into 4 is 1000. Now 250 by 18 can be written as 125 by 9. I am cutting by 2. So 125 by 9 is approximately 13.8 small m. So I can say molality is equal to 13.8 small m. I hope you understood the question. We will do the next question then. So I hope you are able to see the question here. So how much volume of 10 molar HCl? So this is an HCl solution. Okay, HCl. How much volume of 10 molar HCl solution should be diluted with water to prepare 2 liter of 5 molar HCl solution? So understanding this question is very important actually. So again, you know, it is diluted. So I know it's a concept of dilution being applied here. So please understand, initially you are having hydrochloric acid which is of molarity 10 molar, and there is a particular volume. I don't know what is that volume, that is not given in the question. And they are saying they have added some water into it, into this one. So that the final volume now here is, it becomes 2 liter. But the molarity changes to 5 molar. So I know that for the concept of dilution, what remains the same? We have learned the number of solute particle remains the same. Amount of solvent, or the number of moles of the solute, or the number of gram equivalents of the solute. Because suppose you think like you have the solute. Okay, some solutes are there. That means HCl, if it is HCl, I can say, so the number of gram equivalents of the solute remains the same here, or number of moles of the solute remains the same here. Okay. So when you are adding water, there is no solute into it. So here my solute is actually what? HCl is my solute. Okay. HCl is my solute and water is my solvent. Okay, so already this substance contains HCl and H2O. Into that I am adding more H2O, so that final volume is now becoming 2 liter and it is becoming 5 molar. Now I know that I am only adding water here, correct? So whether there is any change in the amount of HCl in the mixture? No, we have learned this concept earlier also. The amount of solute, or the number of moles of the solute, or the number of gram equivalents of the solute will still remain the same here. So if number of moles of the solute is remaining same, means the number of moles of solute before dilution, I can write number of moles of solute before dilution should be equal to number of moles of solute after dilution, because you are not adding any HCl and HCl is my solute here. Okay, so I know that number of moles of the solute, we already learned the formula. Molarity is equal to number of moles of solute divided by volume of solution in liters. Correct, we learned. So I can cross multiply this. So I know that number of moles of the solute is equal to what? Molarity into volume of the solution. So I can write here molarity into volume of the solution. Since it is initial case, I put M1 V1. It should be equal to what? Number of moles of solute after dilution. So after dilution means I am making it to M2 V2. Okay, this we already derived, but again I am explaining it to make you more understandable. So now you apply here what is molarity M1. I know it is 10 molar. Okay, I will write it here so that it will be easy for you to see. So I can say 10 molar multiplied by what is volume V1? I don't know. This is what I need to find out, because how much volume they are asking. So V1 I need to find out. And after adding water, M2 is changing to 5 molar. And after adding water, the volume is changing to 2 liters. So tell me what is the initial volume it is having. So V1 is equal to 10 divided, find it to 10 divided by 10. I can say the answer is 1 liter. So 1 liter was the solution, very easy to understand. Initially I have 10 molar 1 liter solution was there. Into that I have added some amount of water. Now you know how much amount of water they might have added, because initially it was 1 liter, it has changed to 2 liter. So how much amount of water might be added? Again 1 liter of water is added, so that final volume 1 liter plus 1 liter, it is becoming 2 liter. But on adding 1 liter water, what happened to the molarity? It changed from 10 molar solution to 5 molar solution. That is, molarity decreased. So I hope you understood this concept and this problem. So we will go to the next question.